Good afternoon, everyone. Hope you're having a good show so far. Third day near the end. I'm going to be talking for the next few minutes about TV delivery over IP networks using somewhat different approach to probably that you're hearing from a lot of people here at the show around a TV CDN. But before I do that, I'm just kind of thinking about the industry in general and coming here to wonderful Las Vegas. And I was thinking the first time I came to Las Vegas to do, on business anyway, the first, and can't really think why else you'd come to Las Vegas, but first time I came to Las Vegas on business was about 20 years ago to a conference around the start of IP networking. It was quite early days on IP networking and quite early days for the internet. And I was probably in a kind of position whereas I was an early internet user. Very few of my friends, family used the internet. And I was telling them, I remember telling them about, what this thing would do and how it would change our lives. And, one day you'd be able to order pizza online, and people used to laugh at me. And it seemed that within 2 or 3 years' time, everybody I knew was on broadband. They'd even gone through dial-up out the other end onto broadband. They were all shopping online, and the take-up was huge, and the impact that we're all so used to now is huge. And probably a similar thing happened about 5 to 10 years later with mobile phones. And one thing that strikes me here at the show and looking at the industry in general is that we're just in another one of those fantastically rapid, exciting transitions for the TV industry where, only a couple of years ago, it was probably hard to find anybody that watched catch-up or OTT TV, maybe a few people, and now we're all doing it. And we're really just at the start of that transition still. And I think it's, if anything, the one thing I want to talk about this afternoon is about the scale of that change that we're just at the beginning of, and the problems that are going to come from the scale of that change if we don't do something about delivering this stuff and do something different to the way that most people are doing it today. So let's think a little bit about the problem here. I would if I could advance my slide here. There we go. So there's a few things that are coming together, a bit of a perfect storm, I suppose, to use the cliche. First of all, of course, our broadband networks have been getting faster. They're generally undergoing a transition from the first generation of broadband through to superfast broadband, very capable now at the access layer of delivering decent quality TV. There's more content being made available than ever before for the OTT catalog and for catch-up. Our devices, of course, are all capable of running TV as well. And more important than anything are changing habits, just that cultural change that we're going through, where we're starting to expect to watch any program whenever we want to watch it. We're expecting to do that without having to set our video recorder to record it. These aren't the only transitions that are happening in the industry. I mean, this show, everybody's talking about Ultra HD and 4K, and that's going to be another step in this growth curve. So we've got this problem, and what does this problem really look like? Well, in terms of the network, essentially what's happening in the network, which is the challenge, is a shift from multicast traffic to unicast traffic. Multicast traffic is a classic kind of IP TV delivery, where we're sending the data into the network just once. And as that movie, as that video transverses the network, it gets replicated as it goes through the network. It's very much really a close analogy to conventional broadcast traffic. We might be broadcasting over a terrestrial aerial, or we might be broadcasting over a satellite, and it doesn't matter how many people watch that program, you're still only sending that show out once. You're still sending one stream of data across the network. But the world doesn't look like that when we start thinking about OTT, when we start thinking about catch-up. Now we all want to watch the program at a different time. We might want to watch a program in a different format because we're watching it on our iPad or our Android device. We might want to watch the program with personalized ads in it, or at least the advertiser might want us to do that. So we've got a very different world now. We've got a world where every time we want to watch a TV show, that TV show has to be sent to us individually, a personalized stream. So if we have 1,000 times more viewers in the top model, we still send it once. If we have 1,000 times more viewers in the bottom model, we have to send that data 1,000 more times, literally. So we're not talking about even a single order of magnitude change. We're talking about multiple orders of magnitude of extra video and TV traffic to carry across networks as we deliver them. And you might not own a network. You might think that's great, the internet's there. I can throw stuff at the internet. Well, believe me, that's not going to scale. You'll have to take some other approaches in order to make sure that your very expensive content gets to the person that you want to consume it in a decent quality. So what options do we have if we're going to solve this problem, this huge scale problem? Well, we've got a few alternatives, thankfully. So the first one is a conventional CDN, content delivery network, available from many leading CDN retailers in a store near you. And that's actually not been a bad idea for reaching relatively low numbers of viewers. General purpose CDNs were largely developed to deliver software files, your Microsoft Windows update, for example. And they do a very good job at that too. They do a pretty good job on TV at low scale. They have a few challenges. One is cost. So if you want to start delivering 1,000 times more TV streams than you did, you might expect some kind of huge volume discount from your CDN supplier. Now it's up to them to say whether they're going to give you that huge volume discount, but in my experience, you might be a little disappointed. The second one is quality. So those things are optimized to make the best use of the resources that cost money to the CDN provider. They're not optimized to deliver the TV signal in the best way. And the third one is control. You simply have no idea, really, when you throw your content into a CDN, how well it's reaching your viewer. So the second alternative, and the approach we're seeing a lot more people take now, is to start to build their own capabilities to deliver their own content. They might do this with some sort of software streamer. They might do this with a purpose-built appliance. That's a business that my company, Edgeware, has been in for some years. But increasingly, and what I'm here to talk about this afternoon, is adopting a whole new architecture to do that. That architecture being a CDN that's optimized for TV. So that's really what I'm going to talk about, is this TV CDN. What does it look like? What's it going to do for you? How's it going to change the economics and the performance of delivering that network? And actually what we found is that if this is a scale problem, there's an obvious player in the industry who's run up against this scale problem first, and that's Netflix. So Netflix have their own TV CDN that they've built internally. It's called Open Access. It delivers most of their traffic, about 90% of their traffic, and their TV shows are delivered across this network. And they've taken a very interesting approach, and one which we would very much endorse for anybody that is going to set along this path of delivering high-quality TV over IP. So the first thing is they've leveraged cloud-based IT infrastructure. That's no great surprise. It's very flexible, it's cost-effective, it's easy to operate. But what they've selected to do on the cloud-based infrastructure is interesting, because they've not selected that cloud-based infrastructure to actually stream out the TV. So they use it to do a lot of the content management and CRM and so on. But when it comes to actually streaming the TV, they're doing that on hardware and software that they've purpose-built and optimized for that TV delivery, reducing the cost of delivery throughout the whole ecosystem, whether that's the service providers or themselves, and absolutely top of mind is increasing the performance and the experience of their viewers when they watch it. So let's dig into that a little bit more in terms of what that actually looked like, and think about the functions that you need for a TV delivery. You've got a number of functions you need. You need to start with some functions around content. You need to create your library of video on demand content from your live linear feeds in. You need to record that. You need to manage that. You need to have your ads. If you're going to insert ads, you need to have your ads managed in that world. So you've got a number of functions there around content. Then you've got to start moving that content out as you stream it closer to the user. And you've got a number of quite different functions here around routing that content through your network, load balancing it across different servers. You might be delivering this for other players as well as yourself. You might be a public operator, and you need to be able to manage multiple tenants. And then you've got the actual stream itself. So you've got this personalized individual stream that we saw on one of those early slides where everybody's watching their own view. And in that instance, you want to keep a copy of that. You need to think about where that stream's coming from. You need to think about how you can pause it. You need to think about how you can personalize it with ads, watermark it, encrypt it, protect it. So the architectural view of a TV CDN ends up fitting really into these three layers. And we can sort of think about this in terms of the content layer at the top. And I said right from the outset, this was a scale problem. You know, this is like me standing here 20 years ago thinking that this internet thing's coming, and what's that going to look like, and how many people are going to use it? Well, it turns out we're all going to use it, and we're all going to use it lots. And we're going to see the same thing with our TV. So how are we going to scale this? Well, the scale problem when it comes to the content, dimensions in terms of how many assets we've got, how many TV channels are we trying to record, how many programs, how big's our library. And that scales actually pretty well over cloud infrastructure. And this is something that Netflix recognized. This is something that a lot of our customers recognize. It's a great way to take advantage of cloud infrastructure to scale your content layer. But the network layer, the transactions, the requests that are coming from all of the players that come in little 2-second chunks saying, please send me a little bit more video. Send me another couple of seconds of video. Send me another 3 or 4 seconds of video. So what we're getting in that layer isn't really scaling in terms of the amount of assets. We've got something that needs to scale in terms of the amount of transactions. We've got a classic large-scale IT problem. And guess what? Cloud computing's really good at solving that problem as well. So cloud comes to the rescue there too. So we can have solutions there that are implemented in software in the cloud that can scale that, and we can dimension that for these millions of transactions. The final layer is probably the one that I wanted to spend a bit more time on, though, which is the actual delivery of those individual customized TV streams. So individual because you're watching them at a particular point in time, because they need to be packaged to work on a particular device, because they've got a certain stream of ads in, because they've got some watermarking or security, encryption. And actually that doesn't work very well when you centralize that. In fact, it doesn't scale at all when you try to centralize that. So this is what Netflix recognized. This is why they've put currently about 1,500 servers streaming TV out around the world, and it's what a lot of our customers are recognizing too. So that's a function which within the TV CDN architecture needs to be distributed closer to the viewer. And when you distribute it closer to the viewer, you start to see some very significant and radical benefits in solving your scale problem. Because now a show only needs to be sent out once to those individual servers. So a single show can be sent out. So we can have now millions, thousands or millions of viewers watching that show, each a few seconds apart, each on a different type of device, each with a different advertising stream. We still only have to send it once. So we've completely solved this scale challenge of moving from multicast video delivery to unicast video delivery. because we send it out once to the edge, to that point of delivery, and then at that point we keep a copy of it, we keep a cache of all the popular content there, and in real time we can repackage that for the right type of device. We can pause the stream, we can restart it, we can personalize it, we can insert ads. So this distributed architecture starts to bring us multiple benefits. So let me talk about those a little bit more. But before I do that, let's think about about what that edge actually needs to look like. And actually, there's a couple of choices even at the network edge. So one is to use a generic piece of IT server, shared CPU, general computer, which, like all computers, will have some variability in terms of its performance depending on what you're asking it to do. It's not the lowest power consumption and easiest thing to maintain. Or you could use a specific appliance at that point. We're in the specific appliance business, amongst other things, so I do have a vested interest in mentioning them. But actually, it's about picking the right platform for the right application. So if you've got a single point application, generic hardware will run pretty well. If you're not distributing this into hundreds of POPs around the world, then actually having a higher power consumption, having a higher maintenance bill probably isn't much of an overhead. Conversely, if you're trying to run multiple TV services off the same platform, if you're trying to do repackaging, if you're trying to run IPTV alongside OTT, if it's highly distributed, then you might want to think more around a solid-state appliance. So there's some choices there even within the TV CDN architecture. Another thing that might be relevant if any of you are coming out the networking side of the industry is something called network function virtualization. Just thought I'd mention that. If you're not out the networking industry, you're probably thinking, I have no idea what he's talking about, and that's fine. But if you are, it's a really kind of hot topic, and in many ways, this sort of TV CDN architecture fits very nicely with the ethos and the objectives of these virtualization of these network functions. It's a model that can support multiple vendors. We don't have to have the same vendor all the way through the system, which is one of the objectives. It can have open interfaces into the BSS systems for the TV automation. Probably more important than anything, we can scale the different layers here independently of one another. So we can scale the control layer, as I said, in terms of assets. We can scale the network layer in terms of transactions. And we can scale the delivery layer, which is very much in line with the objectives of NFV. So in terms of what does that mean in terms of customers and benefit and who and how are people using this and why, there's really probably three kind of key areas that people are coming to. The first one I mentioned earlier which is very much driving Netflix approach here is around viewing experience. So it's around controlling and delivering the best possible delivery of that TV stream. So eliminating buffering, being very deterministic in the way that TV stream is being delivered. So making sure that quality of experience is delivered no matter what else you're expecting that platform to be doing. So it doesn't matter if it's storing, if it's writing, if it's if it's keeping another copy of the next program you're pushing out. You still want to be very confident in terms of the deterministic bandwidth being made available to stream to your customer. And the second element of performance is around delay. So sports is an often cited case in this. We've got a customer who's delivering sports content from UK around the world, and for them, delay is absolutely important. And typically, if you just go and throw your content into a CDN, it might come out the other end 20 seconds, 30 seconds later, and you might not want to have that level of latency into your service. So that would be another aspect. And the third aspect of this, sorry, not the third, the next aspect of this that's driving this is really about scaling cost effectively. So I mentioned earlier about the problem with the public CDN and the tariff structure associated with those. But this is a way of really breaking that problem of having a linear cost. Every time you add a new viewer, you've got an extra cost of delivery. Much more cost effective once you get to a point of scale in terms of using the CDN architecture versus a public service. And the third element was one of control, one of insight and analytics. By understanding the whole path, the whole delivery path that you're sending your TV across, you can start to understand things that you couldn't understand just from the player. So if somebody stops watching your TV content after 10 minutes, how do you know whether that TV content was just unacceptable to them or whether they experienced some sort of network glitch or a delay? If you're in control of all of your delivery through your own CDN, you can correlate that data together. So you can understand whether the network performance is affecting the viewing and how it's affecting the viewing. You can also understand how the device watched might affect the viewing. You can understand what network that device was connected to and how that might have affected the viewer. So you can start to manage your own delivery network better, but more importantly, you can start to understand more about your customer. You can understand if they're about to churn because they've had poor performance. You might want to offer them a rebate. You can understand exactly what they're doing with their content and why. So 3 reasons why people tend to be doing this. The viewing experience, the scale, and the insight. So I'm really just going to close here by saying that one, who we are, where we are. It's a quick company advert, excuse me there. So Edgeware's been in this space since about 2006, 2007. We've got about 150 customers that are doing this, so we've got quite a lot of experience. We'd love to take questions and talk to you more about what we're doing, what other people in the industry are doing. We're located in a booth about 50 meters less, probably about 30 meters in that direction, just next to the Cisco booth. So please do come and ask us if you've got any other questions. And other than that, I'm going to thank you very much for your time. I hope you enjoy the rest of the show and appreciate your time listening to me. Thank you.